Okay, let's jump right into it. Picture this. The Earth, our planet, is showing signs of a fever, And according to the latest insights we've been looking at, that fever seems to be, well, accelerating faster than anticipated over the next few years.
It's a potent image, and it really captures the urgency. You see that reflected in the recent climate predictions.
Exactly. And that's the core of our deep dive today. We're unpacking some really significant updates on the expected shift in global temperatures, specifically over the period from 2025 to 2029.
Yeah, the headline finding here, the one that really grabbed attention, is the analysis suggesting a very high probability. We're talking a 70% chance that the average global temperature across those 5 years, 2025 through 2029, will actually exceed a critical threshold.
Which threshold is that?
It's 1.5 degrees Celsius above pre-industrial levels.
Right, 1.5 degrees C. And that isn't just some abstract number pulled out of thin air, is it?
No, not at all. You'll definitely recognize it from the 2015 Paris Climate Conference. That was the ambitious line in the sand that world leaders drew. The aim was keeping warming well below 2 degrees C, but ideally aiming for 1.5 degrees C.
To avoid the worst stuff, right.
Exactly. The idea was staying under 1.5 degrees C would help us avoid the most catastrophic consequences. Supercharged storms, coastlines being swallowed by rising seas, ecosystems just collapsing. Think of it as the planet trying to stay out of the critical danger zone.
And it feels like we're getting dangerously close, maybe quicker than many hoped. I mean, 2024 already briefly touched 1.55 degrees C above the baseline. That made it the hottest year on record so far. And the prediction now says there's an 80% chance that at least one year in the next 5 will actually be hotter than 2024 was.
That 80% figure, yeah, it really underscores the accelerating trend we're seeing. It's quite stark.
So the mission for our deep dive right now is to truly understand what these numbers mean for you. What do they signal for the planet? Why is this speed up happening? Where are the impacts hitting hardest? And what are the real-world implications for our daily lives, for the future we're building? We're going to try and cut through the noise here and give you a clear picture of this crucial climate update. Okay, let's get into this forecast.
So that 70% probability,
Yeah.
the one for the 2025-2029 period, averaging more than 1.5 degrees C warmer than the 1850-1900 baseline. That baseline being the pre-industrial era before, significant human emissions really kicked in. That's a really significant piece of information.
Right. And coupled with that, the 80% chance of at least 1 year within this 5-year window setting a new heat record, surpassing even 2024's 1.5 degrees C.
Exactly. And while 2024 crossing 1.5 degrees C for a single year was already like a major warning flare, this new data focuses on the average over 5 whole years potentially crossing that threshold. That's a different kind of signal.
Okay, so let's be clear, though. Does this mean the Paris Agreement's long-term goal? Has it officially failed? Are we there?
Well, not quite yet. The Paris Agreement's main goal, it's measured over decades, you see. It looks at the long-term average warming. So a single year, or even this potential 5-year average crossing 1.5 degrees C, it doesn't technically mean the long-term goal is out of reach yet.
Okay.
But think of it less as failing the final exam and more like getting a major warning notice. A really serious heads up from the planet.
Like the planet giving us a talking to.
Sort of, yeah.
Yeah.
It's a stern signal that we are on a trajectory that is far too fast and, frankly, in the wrong direction.
A very loud warning sign, then. So if we're seeing this acceleration, what's driving it? Why is the planet heating up this quickly now?
The primary driver remains, well, it's overwhelmingly human activity, specifically the continued release of greenhouse gases, things like carbon dioxide, methane, into the atmosphere. These gases act like a blanket, trapping more and more heat.
And that heat-trapping effect of that blanket, it's been getting thicker, hasn't it?
Significantly thicker. The warming effect from these gases has increased by a striking 51% just since 1990.
Wow. 51%. Half, again, as much warming effect in just a few decades? That really puts the acceleration into perspective.
It absolutely does. And 2024 reaching that 1.55 degrees C mark, it just reinforces how steep this trend has become. And looking back, the past 10 years globally, they've been the warmest decade on record, period.
So we have the data, faster warming, but what does this actually mean? What's the real-world impact of this accelerating heat for us, for the planet?
Well, the core insight here is that this isn't just some abstract number on a chart, right? This translates directly to a growing, tangible, and negative impact on almost everything, our economies, our daily lives, natural ecosystems, and the fundamental systems of the planet itself.
Okay, so the heat is affecting everything, everywhere. Or is it more complicated?
It's definitely more complicated. It's not everywhere equally. That's a really critical point. The impacts are felt very unevenly across the globe. Some regions are experiencing disproportionate warming.
Like where, for example?
The Arctic is the prime example. It's warming dramatically. It's accelerating at a rate about 3.5 times faster than the global average. And the forecast for the next 5 winters, specifically November to March, is that the Arctic will be roughly 2.4 degrees C warmer than the global average temperature during that same period.
Wait, 2.4 degrees warmer than the global average in winter. That's a huge difference, especially such a sensitive region.
It's enormous. And the immediate consequence we see is significant predicted shrinkage of sea ice. We're likely to see this in places like the Barents Sea, the Bering Sea, the Sea of Okhotsk.
And that shrinking ice, that matters because...
Because it creates a powerful feedback loop, a dangerous one. Less bright reflective ice means more dark ocean surfaces exposed. That dark water absorbs more heat from the sun. That absorbed heat leads to even more warming, which melts more ice. And, well, the cycle continues and strengthens.
A vicious cycle indeed. Okay, what about other effects, like how this heat is changing where and when it rains? Are we seeing shifts there too?
Oh, yes, significant shifts there, too. The forecast, looking at May to September between 2025 and 2029, suggests some regions are expected to get wetter. This includes areas like the Sahel region of Africa, northern Europe, Alaska, and northern Siberia.
Okay, more rainfall in those areas, which implies it's getting drier somewhere else.
Precisely. On the flip side, the Amazon region is likely to see a decrease in rainfall during that same May-September period.
Right. And what about a place like South Asia, particularly India, where the monsoon seasons are so absolutely critical?
Yeah, that's a key area. In recent years, South Asia, with the notable exception of 2023, which was a bit different, has generally experienced above normal monsoon rainfall. The current outlook suggests this trend, this tendency towards wetter monsoons, is expected to continue through 2029.
Wetter monsoons.
But, and this is important, it's crucial to remember that drier seasons within that time frame are still certainly possible. Doesn't mean every single monsoon will be excessive.
So potentially more intense downpours during the wet season, but still the risk of drought during the dry season, it sounds like. Well, like the planet's weather patterns are becoming more extreme, maybe less predictable overall.
That's a fair assessment, more volatile perhaps. And these shifts in temperature and rainfall, they have cascading consequences across everything.
Okay, let's delve into those consequences. Why should someone listening right now care deeply about these forecasts beyond just, noticing the weather feels a bit weird?
Because the impacts reach into almost every aspect of life and the natural world.
Yeah.
I mean, look at ecosystems first. We're witnessing widespread coral reef bleaching due to warmer oceans. Forests are becoming more susceptible to frequent and intense wildfires. Species are struggling, some disappearing as their habitats, migration routes, and food sources are just fundamentally disrupted.
Nature is really being pushed to its limit.
It really is. And then there are the significant economic repercussions, aren't there? Absolutely huge ones. Extreme weather events, floods, droughts, intense storms, hurricanes, they can devastate crops. That leads to food shortages, food price spikes.
Farming, particularly in regions where it's foundational to the economy, like parts of India you mentioned, becomes incredibly unpredictable, risky even.
And the costs?
Exactly. The sheer cost of rebuilding infrastructure after these increasingly severe disasters is just enormous. It's a massive drain on economies everywhere.
Disruptive and incredibly expensive. What about the direct impact on people's daily lives? How does this heat feel?
This is perhaps the most tangible impact for many people. We're seeing a clear increase in the frequency and intensity of heat waves. You might remember the intense heat in India and Pakistan back in 2022. Temperatures soared to 47 degrees C in some areas. That's incredibly dangerous heat.
I remember hearing about that. Intense. Yeah. And these prolonged extreme heat events aren't just uncomfortable. They cause serious health problems, especially for vulnerable populations. They put immense strain on power grids, leading to blackouts. They simply make basic daily activities difficult, sometimes even dangerous.
And thinking about the planet on a larger scale, what about the ice melt and sea levels rising?
Yes, rising sea levels are a major slow-motion threat, but accelerating. Driven by the melting of ice sheets and glaciers, and also the thermal expansion of ocean water. As it warms, warmer water takes up more space. This puts coastal cities globally at risk. Places like Mumbai and Chennai are already actively considering the long-term implications.
And this brings us closer to something even more concerning you hear about, climate tipping points.
Exactly. Climate tipping points. What exactly are those? Well, they're critical thresholds within the Earth's complex systems. If we push the climate system past one of these points, even a relatively small amount of additional warming could trigger large, potentially irreversible changes with massive consequences.
Irreversible changes, like what?
A classic example scientists worry a lot about is the potential collapse of the West Antarctic ice sheet. The concern is that beyond a certain warming level, this immense ice sheet could destabilize rapidly. And if that happens, it could lead to several meters of global sea level rise over time, which would, frankly, inundate coastal areas worldwide.
Wow, several meters. That's hard to even comprehend the scale of that. These sound like potential chain reactions with devastating, long-lasting effects.
They are. And all of this data, all these specific impacts we're discussing, they bring us right back to those goals set in Paris back in 2015, keeping warming well below 2 degrees C, aiming for 1.5 degrees C.
And the probabilities we're now seeing, the ones we started with, they show how quickly the situation is accelerating compared to even very recent forecasts.
That's a key insight here, the speed of the change in outlook.
Okay.
Back in 2023, the projection was a 66% chance of hitting 1.5 degrees C in at least 1 year by 2027.
Okay, 66% chance for 1 year.
Now, just a couple of years later, the picture is even starker. It's a 70% chance for the average temperature over the next 5 years, 2025-2029, to exceed 1.5 degrees C, and an 86% chance that at least 1 year in that 5-year period will be above 1.5 degrees C.
That is a significant leap in probability in such a short time. It feels like a major shift in the forecast itself.
It truly highlights the accelerating pace we're dealing with. And while, as we said earlier, this isn't technically the failure of a long-term Paris goal yet, it is like getting a flashing red warning light on the dashboard of our journey toward a stable climate. It's signaling very clearly we're heading in the wrong direction, far too quickly.
And this is precisely why continuous monitoring and prediction are so vital, isn't it? This kind of scientific forecasting provides the essential tools. Tools for decision makers, for governments, for businesses, to understand the risks and hopefully develop strategies for adaptation and mitigation.
Exactly. Knowing these specific predictions, the regions most likely to be affected, the types of impacts to anticipate, allows for more informed and targeted responses. It's crucial intelligence.
So the big question hanging over all of this forecast, is, does this mean it's a done deal? Are we locked into this trajectory, or is there still a path forward? Can we actually change course?
It's the most important question, really. And this forecast, the science behind it, it shouldn't be seen as a prediction of inevitable doom. It's not fate. Rather, it functions as an urgent call to action. It underscores the immense challenge, yes, absolutely. But it also implies that our actions now still have the power to influence the trajectory beyond these immediate 5 years.
Okay, so what are the absolutely critical steps? What needs to happen starting today?
Well, priority number 1 remains cutting emissions drastically. We have to reduce the amount of greenhouse gases, CO2, methane that we're pumping into the atmosphere, full stop.
Oh,
It means accelerating the transition to renewable energy sources like solar and wind,
right.
rapidly adopting electric vehicles, phasing out reliance on fossil fuels, especially coal. That's tackling the root cause of the problem.
Okay, reducing the source. That makes sense. What else is crucial?
We also absolutely need to adapt. We have to prepare for the changes that are already underway and those that we know are coming based on these forecasts. Some warming is already locked in.
Adapting how?
This includes things like building infrastructure seawalls, drainage systems that are more resilient to flooding or extreme heat, developing and planting crops that can better withstand heat and erratic rainfall. You see experiments happening in places like India with climate-resilient agriculture. Scaling those kinds of efforts globally is absolutely vital.
Right, adapting to the reality of a warmer world because some changes are now unavoidable, it seems.
And critically, global cooperation is essential. Climate change doesn't respect borders, obviously. The Paris Agreement set the framework, but international collaboration needs to be much deeper, much faster. That includes providing financial support for vulnerable nations.
Nations that often bear the brunt of the impacts.
Exactly. Despite having contributed the least to the problem historically, that climate justice aspect is key.
It's a global challenge, demanding a truly global collective response. No one country can solve this alone.
Absolutely. And it also comes down to actions at every level. including personal action.
Does individual stuff really make a difference with such a huge problem?
While large-scale systemic change is paramount, individual steps absolutely add up. They create momentum, they shift culture, they signal demand for bigger changes. Reducing our reliance on single-use plastics, conserving energy in our homes, choosing walking or cycling or public transport over unnecessary car trips. These are small pieces of a much larger puzzle, yes, but they matter. They contribute.
So it requires action from individuals, communities, nations, the international community, all pulling in the same direction all at once.
Precisely. This forecast for 2025-2029 is stark. It is a clear warning signal, but it is not the final word on our future.
It feels like we've really covered a lot of ground here, moving from those high-level probabilities right down to the very specific impacts on different parts of the world and different aspects of life.
Yeah, and the key takeaway, I think, is clear. The science tells us the next 5 years are going to be significantly warmer. They're bringing us right up against that 1.5 degrees C average threshold. And that truly serves as a stark warning sign for the planet. A final call, perhaps.
And while the challenge ahead is immense, this report feels like that necessary wake-up call we discussed earlier. We absolutely still have agency. We still have the ability to influence what happens beyond these next few years.
The path forward is clear, even though it's challenging. It requires determined action to cut emissions rapidly. It requires scaling up efforts to adapt to unavoidable changes, fostering genuine global cooperation, and taking those meaningful personal steps that contribute to the collective effort.
It's a complex picture, isn't it? Filled with challenge, but also possibility if we choose to act decisively.
Ignoring this forecast or dismissing it as just another scary report, that would undoubtedly be the most dangerous approach of all.
So let's leave our listeners with this. Taking in this forecast, this really clear look at what the science suggests is coming in the next few years, and thinking about the specific impacts we discussed, from intensifying heat waves in cities, maybe like where you live, to shifting rainfall affecting farming near you, to those long-term threats to coastal areas. What is one concrete change? Either something in your own life, or maybe something you believe your community absolutely needs to push for to better prepare for and navigate the reality of this warmer world in the coming years. That's something powerful for you to consider as we wrap up.